Hey everybody, I think I've got a good one for you tonight. So about a week ago, I did a video on the MCP DAX server or Power BI server that Maxim Anatsko had put together. And I really saw this as groundbreaking because of the way in which it can not only access the elements of the semantic model, but it can actually execute DAX code and performance traces. And this is something we've never been able to do before. And in the past, even with the most sophisticated frontier models, what they've had to do in order to, quote, execute DAX is they convert it into Python or JavaScript and then run the equivalent code, which really opens the door for errors, in the sense that you may have an error in the DAX code that the AI writes, or the DAX code may be perfect, but there may be an error in the translation, and that Python or JavaScript may not evaluate in context in the same way that DAX does. And so what he's done is he's built an MCP server that actually executes DAX natively within Power BI, and also can execute performance traces, splitting in the formula engine, the storage engine, running with cold cache, all the best practices for performance evaluation optimization. So what I want to do is I want to show you a problem that Omid published earlier this week. It's a 4-star Power Query challenge, Power Query M challenge. Really difficult one. And it's actually even more difficult to do in DAX, because in Power Query, most of the ways people solved this was through the use of list.generate and other functions that you can invoke recursively. And that's something that you can kind of fudge in DAX, but you can never get true recursion. And so this is actually a very, very difficult problem in DAX. So basically the nature of the problem is pretty simple. That what you want is you want to group by the first group, you want to have 1 row. The second group, you want to have 2 rows. Third group, 3 rows. Fourth group, 4 rows, and so forth. But you want it to be dynamic for every possible number of rows in the data set. And what we want to do here is, I think, if we look at this from a DAX standpoint, is we don't want to go with calculated columns, because what we want to do is be able to set up a date slicer, for example, and dynamically adjust the size of our fact table, filtering based on date. And so this actually becomes a very difficult problem, one that I estimate that probably under 1 in 1,000 Power BI users can accurately solve in DAX without relying on AI. So I want to walk through kind of how we can use Maxim's MCP server to solve this kind of really difficult problem, and to evaluate it natively in DAX to make sure that we've got the DAX correct, and then to use that iterative capability to optimize the measure as well. So what I want to do is jump in, and let's go into Claude Desktop, and let's connect to we have to open up our file in Power BI first, because it connects to a live file through the XML endpoint. And let's open up the Maxim date test, and I will show you. It's a pretty simple structure I've got here. So basically what I did is I took the data from Omid's exercise, and if we look here, we've just got a really simple table here. And then what I did is I created a validate table, which random values for sales over 10,000 rows. And so it's the exact same structure as the data table, but I wanted to have a bigger table that we could validate on to make sure that the measure it generated was in fact calculated correctly over a large table, and then also a large enough table so that we'd be able to look at the performance aspects. So let's jump in. Let's connect to Power BI. I've only got one file open, so it should know which file to connect to. Okay, so it's listing the available models here, and Maxim DAX test. That is the one. So we're just getting the configuration via Desktop Commander, and this is just allowing Desktop Commander to access this directory. So it's just looking to see whether we have any useful context. So we want to say yes. Connect to Maxim DAX test model. Okay, we're connected to the model. It's just going to list the tables. And so we've got the data table, the validate table, and the measure table. And it's gonna dig in here and just take a look at the contents and structure of each of those tables. Okay, and date and validate both have the same structure, which we know that was intentional. Okay, and we just have one total sales measure. Okay, so it's got a good handle on what we have in our model. And what I wanted to do is I wanted to create that measure that solves the grouping. And so let's say create a DAX measure that adds group number to the data table in a way such that the first group has 1 row, the second group has 2 rows, the third group has 3 rows, and that they correspond to the first row of the table, the second and third row of the table for the second group, the third, fourth, and fifth row for the third group, and so forth. And we want that to be generalizable to a table of any number of rows. Okay, and with that prompt, let's see what it can write. And as I said, my estimate is that about 1 in 1,000 Power BI users could write this measure in an efficient, effective way and get an accurate answer. When I had Claude estimate that, it actually estimated 1 in 2,000. So Claude wants that to measure. Let's allow that. So what it did, it ran the DAX, and then it immediately refactored it with what it found to be a more effective formula. So it's now looking at row context and creating another measure, and then it's going to run the DAX here to verify that it's actually creating it properly. And this is really the advance that Maxim has brought to the table here in terms of being able to run that DAX query natively. And we can see here that it didn't actually produce the desired result. So it's actually going back and iterating on the formula, rerunning DAX until it gets it proper to our specifications. Okay, and there we got it. Rows 2 to 3. Okay, and let's see what it does in terms of the summary of the grouping pattern. Okay, and so now what we want to do is, it's simplifying the query. So while it's doing that, we can think about our next query, which is for the groups created, total the sales for each group, and then produce a query that gives group number and total sales per group. Okay, so here's the quadratic formula it came up with in order to serve as the basis of that measure. And let's throw the group totals in there. And again, it's running the DAX queries here, and you can see it's writing queries and running queries. Okay, and so now what we want to do is we want to go back to Omid's post, and let's take a screenshot of this result and see if this squares with what the measure produced was. So compare the results of the query above with the following screenshot. Compare row by row and indicate where there are any discrepancies. Also check the totals of the grand total of sales for each each analysis. Okay, we just need to copy this. Let's copy this graphic, and let's pop that back into Claude, and let's give that a run and see how that compares. And you can see it's a perfect match with the totals matching up. Now what we want to do is, what I've done is I have in GPT-5 I created this thing called the Group Validator app. And so what I've got is I entered in the 10,000 row validation table that I created. Just had ChatGPT create randomly using the date and the random sales between 0 and 100 on any given day. And then what we can do is we can copy the CSV out of this and compare that with what Claude just created. And so let's say run the same query on the validation table. Let's say the full validation table. Compare row by row with the following CSV. Okay, so it's just adapting that same triangular measure for the validate table, and then it's going to run the full analysis on that. So again, this will be a DAX query, and we've got perfect match on that. So the measure validates out beautifully. Okay, so now let's try some performance optimization. So let's see how fast this runs. So run a performance trace on the validate, and let's see how fast this is. Okay, so what we've got here is 44.67 milliseconds. That is pretty quick. Okay, so 1 million rows in about 4.5 seconds potentially. That is pretty quick. So let's see if we can do this even faster. So evaluate whether there is an alternate structure for the measure that would run even faster. And so what it's going to do, it's going to create several approaches, and then it's going to evaluate those approaches iteratively to see if any of those are faster than the one that is running in about 45 milliseconds. Okay, it's got 5 different versions of the measure, and it's going to run performance traces on all those. So it's just stepping through, and it's analyzing each of the alternate structures, clearing the cache each time. Okay, so it's iterating, it's learning what's working well, what's not, and then it's creating what it expects to be the ultra optimized version. And it's going through and it's checking to make sure that the optimized version still produces the correct results. And since it's got a firm baseline as to what correct results look like, it can do that really accurately, and we can be confident that what it's producing is in fact DAX that will give us a proper result. Okay, and there we go. So we've got a measure that we know is running accurately on a very difficult problem. We have a whole range of different performance evaluations, and we have a 7% reduction from an already fast measure in the initial generation. So 10,000 rows, complex triangular math in under 37 milliseconds. That, I think, is a pretty spectacular result. So anyway, I think this is going to be the type of analysis that beginners to experts are going to use at different levels for when they need assistance, and the ability to run it natively in DAX. I think you can see the potential here already, and I really want to shout out Maxim. I think he's done just a spectacular job putting this together. He's going to be soliciting volunteers for beta testing, and so this week also Microsoft announced an official MCP server for Power BI, and I've been talking to Rui Romano about that. I'm going to be assessing that over the weekend and reporting back out to you on the status of that, but that also looks extremely promising. As always, thanks for watching, and I will see you in the next video.